After a gravity-defying round of tree climbing, our competitors in the 2018 UT Trigintathlon are ready to take on their next event. Channel 18 News presents Event 13, the Gymnastics Round.
Hello everyone, and welcome to Round 13 of the University of Toledo's Trigintathlon. I'm Anna Walker, reporting live from campus as Sammy Porter begins to make her run in to begin the gymnastics round. Sammy starts her routine off strong with a round-off back handspring after a quick recovery from the last event. Whoa, look at those rotations. Let's slow that down a little bit.
The rotational kinematics behind Sammy's back handspring can be simplified with the understanding and application of a few key components. Angular velocity is the rate at which an object or body is rotating. Relatedly, angular acceleration is the rate of change of this angular velocity. These both can be used in calculating for a precise position or time during a flip or turn. The specific angular velocity of Sammy's back handspring can be calculated by using her linear velocity relative to the radius of her turn. The mathematical relationship is omega, or angular velocity, equals linear velocity divided by the radius. Similarly, the angular acceleration may be found by relating her linear acceleration to the radius of her turn with the equation alpha, or angular acceleration equals linear acceleration divided by the radius.
Now that we understand a little bit more about the speed of her rotation, let's get back to see the rest of her routine. Another successful back handspring after a thrilling line of fresh new moves. Look at that girl go. But did anyone else notice that this back handspring was a little slower than the last? Let's break that down.
Kinetic energy is the energy due to motion in a system. Since the focus of motion of a gymnast is often in the rotation, people tend to overlook the effects of translational motion in their system. The total kinetic energy of a system is the sum of two components, translational kinetic energy and rotational kinetic energy. The linear velocity of her routine allows Sammy to keep moving in the direction that she was moving prior to her turn, so translational kinetic energy must also be taken into account. Because of this, Sammy's energy is higher during her running round-off back handspring than during her front walkover cartwheel handspring combination, since the running round-off back handspring had a larger linear velocity that affected her turn, and therefore had a larger translational kinetic energy component. The front walkover cartwheel handspring combination still does have a linear velocity that affects the turn, so it has a much greater kinetic energy than the back handspring performed from a stationary position, which lacks a translational kinetic energy component. Overall, when comparing the energies of rotations, linear motion must also be taken into account.
Stuck. Let's go check out the physics behind what happened.
Sammy's failure to complete her back walkover fluidly can be easily explained using the principles of angular momentum and torque. For this specific trick, her body creates a larger radius of motion because of the extension of her legs. The larger radius causes the angular momentum of her system to increase. The radius also impacts her moment of inertia, which is a body's tendency to resist angular acceleration. The moment of inertia directly relates to the amount of torque required to rotate her system completely. Torque is the rotational force of a system. A larger moment of inertia requires a larger torque to provide a big enough acceleration to complete the back walkover. However, since she did not apply enough torque at the onset of the move, she was unable to complete the move and is stuck midway through.
Isn't this thrilling? Stay with us as we follow the competition to stage 14 after the break.
It's sticky, it's wet, it's a fan favorite. Prepare to dissect the fluid dynamics behind Juice Pong during Event 14, brought to you by Kool-Aid.
I'm telling you, I could have been in these trigintathlon things too. Watch.